Hi, we are Team 19458 Equilibrium.exe, a community based team from Potomac, Maryland. This past season, we were a division finalist at the World Championship, and Fun FTC ranked us in the top 25. My name is Miriam. This is my ninth year of first and fifth year of FTC, and I am the software lead on the team.
My name is Alex. This is my fifth year on the team. I'm a main engineer. I was co-captain of the team, and I was driver 2 as well.
This season, we identified two major strategies: a roamer and a stacker. A roamer would spread cones around to different junctions trying to gain ownership points, and a stacker would stack a bunch of cones on a single high junction. We decided that we could get under 5 second cycles either way, and decided to go a for a roamer strategy to maximize our points with our limited number of cones.
In order to facilitate this roamer strategy, we decided that we wanted to be able to drop cones on junctions on both sides of a row. And so we did this by having a servo that can rotate our arm plus or minus 90 degrees. We decided that this would be a more elegant solution compared to a turret, since a turret has all the additional mechanical complexities, and we didn't need the full 360 degrees of movement. Additionally, one of our past members has had previous experience with turrets and gave us the benefits and drawbacks of each, and therefore suggested this. On the end of this servo, we have a horizontal extension, which replaced our old static mount. Our old static mount required us to have to shift the robot 1 or 2 inches in order to drop on the junctions on either side of a row, while this allows us to extend out our claw in order to drop, while still retracting in order to fit within 18 by 18. It's powered by the servo and a linkage and allows us this much movement. Our claw is an inverse claw. We like to call it a nose picker because it grabs from the inside of a cone right here. And we decided that it would be more advantageous than a traditional claw, since in a traditional claw, let's say you grab in the middle, you'd always have to grab there, because if you grab from the top, you run the risk of not closing the claw far enough or to grab, or if you grab at the bottom, you could run the risk of overdriving and then breaking a servo. And so we decided to grab from this top, which has a consistent small diameter. Additionally, we have this shroud on the outside of the claw, which also holds our beacon holder. It's 2 latches, which are held closed by surgical tubing, and then these 2 kind of Bowden tubes, kind of like the brake system on your bike, and then the spool, which opens and closes it, as you can see here. And so one advantage of this is that we can grab both at the same time, and then drop each one individually. And so how our claw works is that we have this servo right here, and it powers this linkage, which pushes up and down this plunger, opening these 3 claws. Now, one drawback of the fact that we always have to grab from this top area is that we have to be very precise with how we're picking up the robot, or picking up the cone with our robot. And so we have this cone aligner that allows us to pick up from a pretty wide area, but still feed into the same area to pick up with our claw. And what's unique about this cone aligner is that it can fold up with this virtual forebar right here, and it's kind of like your elbow and shoulder. Additionally, we found issues that if we were to hit the wall with this all the way down, it could break a servo, and so we added in a bar right here in order to help prevent that.
The entire process of picking up a cone is completely automated, starting with the color sensor in our nose picker, which allows us to detect when our drivers have reached a cone. Once that happens, our lift lowers until the limit switches in our nose picker detect a cone, at which point the nose picker will expand to grab the cone, and the lift will raise to prevent dragging the cone along the ground or knocking over a cone stack.
Speaking about our lift is unique in the fact that it uses 3 different sets of slides. It uses 2 sets of Mitsumi 3 stages, both of which are a different length, as well as one set of MGN carriage slides, which means that we can utilize the full length of a slide so that we don't have this extra foot sticking out, as you can see. Our slides allow us within these middle two rows to hit basically any junction and drop a cone on it within 5 seconds, and it lifts high enough that we have roughly 3¼ foot of space over, since we grab from the top of a cone in order to drop on a junction. Additionally, we have these two tape measures right here, since we found that sometimes when picking up a cone stack, it would get caught between one or two cones and lift the rest of the cones into this void here, getting stuck in our robot and causing issues. Additionally, two unique things about our robot is that we have aluminum odometry pod mounts, over which we replaced the 3D printed ones with, since we found that it had a little bit too much wiggle and would add in inaccuracies to our odometry, and that we use 75mm rev mecanum wheels over the traditional 96mm go build a mecanum wheels that everyone else uses in order to widen our wheelbase.
Uh, our auto has fail safes, allowing us to always reach the reach the cone stack, and when we don't reach the cone stack, we will always get our 20 points from harking. In addition, our development process went quickly because we were able to use our symmetrical robot to mostly do our testing in one quadrant of the field and then easily translate our auto over to the other restarting positions. Thank you, and we will now be taking questions.
Cool. We got a couple questions coming in from chat. Screen 404 asking, did you improve on the design of your robot from the first qualifier through Worlds? And if so, how did you choose what to improve?
So we did make a couple improvements. One of the biggest ones was replacing our old static mount with our horizontal extension. So our old static one, like I said, we had to shift 1 or 2 inches horizontally to each side in order to drop on a junction, while our horizontal one allowed us to drop at a preset distance, meaning we didn't have to shift horizontally. And the issue we couldn't make our static mount longer was that it wouldn't fit with an 18 by 18, but with the slide like this, we can simply retract them in order to fit.
Next question coming in from Civ asking, can you elaborate a little bit more on some of your robot materials? I know you touched on a couple of them, but can you give us a little bit more of a general overview of some of the other materials you use on your robot?
So generally, we had our robot is mainly either custom cut aluminum that we cut by hand or got machined by a third party, or custom 3D printed. As you can see, this entire shroud and all of these blue accents are 3D printed. And actually, this right here is a aluminum side plate that we cut and sanded machined by hand. We then wrapped with a carbon fiber kind of vinyl wrap to look like carbon fiber, so it's not actually carbon fiber, but it looks like that.
Fair enough on there. I'm sure this is an inside question, but I'll ask it anyways. Drew Diedrich asking, hi Alex, why is your shirt blue?
It's blue because I'm wearing the Equilibrium shirt, and blue is our team color that we decided.
All right, fair enough. Next question coming in from John Cannon. Did you find having a unique odometry setup gave you an edge over other teams during autonomous?
So the reason why we decided to go for our aluminum odometry pods is because originally we had our mounts were 3D printed, and then actually at one point we decided to retune our Roadrunner, and we noticed on the localization test that we were consistently getting drift. And then when we looked at our odometry pods to see if it was a mechanical problem, we noticed that they were actually had a really large amount of wiggle in them, and so they replaced those 3D printed mounts with aluminum mounts, and that allowed us to have a much more sturdier mount, and we had a lot less drift after that.
So as you can see on the bottom of our robot, these are our Rev 75mm mecanum wheels, and if you can see here, just a tiny bit of the odometry pod is The bottom part is aluminum. But otherwise, we have our 3 odometry pods right here, and the backing plate is aluminum. But the most you can probably see of that aluminum is right there.
Question coming in from C-League Sintin. I'm going to elaborate a little bit more on this, asking more about the different iterations you went through to get to your final designs. I'm going to ask on top of that, looking at your team, I had a very deep run at championships in the Ochoa division, and of course attended MTI as well. What did you look at doing for modifications specifically for championships and MTI?
So one of the modifications that we did for MTI was the odometry pods. We replaced them with the aluminum. However, some of the modifications that we made for World specifically was this horizontal extension, and we also eventually reduced some of the sharper corners on the cone aligner that we have in order to also help reduce the fact that we might pick up a cone accidentally. So combined with these tape measures right here should have greatly reduced the fact that we picked up a cone or part of the cone stack and dumped into this void, preventing our robot from continuing further.
All right, so we start to wrap up. By the way, chat, if you have any more questions, we can take those, and we'll give Equilibrium a couple more minutes to wrap up and talk a little bit more about their bot. So Equilibrium, as you look into the center stage season, what are maybe some of would you say that are the most important things that you took from this season in POWERPLAY that you're going to apply to center stage?
So if we assume that odometry is going to be used during center stage, which is possible, but it's also possible that you could do camera localization with the addition of April tags, is that you want to make sure that your odometry pods are really sturdily mounted, because that reduces just some of the inaccuracy. And also another issue that we had with the 3D printed ones is that sometimes the bottom would snap off, and we'd have to replace that 3D printed mount.
And I'll follow up on that too. Miriam, is there anything from April Takes that excites you of having that for the first time in FTC? Because last year in FRC, they introduced that. A lot of great implementations. What excites you most about April Tags on Equilibrium?
So I really like the idea of April tags as localization, because we found, like, I actually did some initial testing on it earlier this summer, and it was like very good, like, because what we were doing this past season in auto, we would use ultrasonic sensors and IR sensors to make our small corrections for odometry drift, and it would be really nice to be able to use April tags instead, because that's only like 1 or 2 sensors that we actually need to add our camera, which we'll probably want anyway, and it will also, it's just more accurate and precise than the sensors that we were using this past in POWERPLAY, from what I can tell so far.
All right, Equilibrium.exe, thank you so much for telling us more about your team, and hopefully everybody's finding great value. I think they will. So thank you so much for that. Good luck in the center stage season. And if you are watching live, up next, we're going to have 14496 for Octopi coming on in just a little bit. Stay tuned. Your destination for first content, updates, and gaming.
Welcome to the fun.
Fun is continuing to grow and looking for new ad partners for the 2024 season. If your organization has a positive message to spread to our over 250,000 unique viewers, go to firstupdatesnow.com/contact to get more information. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.